So let's work on the solution of this homework assignment in our current laboratory. So, well, first of all, I would like to move this to the side and just use this file as a reference and continue working with an M08.asm. Okay, so let's possibly also rename this file as macro demo, so we don't make a mistake that this is just a reference file for us. So first of all, let's start with the data. I'm going to remove this 6-byte buffer because we're not going to use it. We need buffer for user input, and we need another buffer to convert from double word to ASCII. Okay, so we're going to use these two buffers. Now, in this data segment that we have, global data segment, let's define our variables. We need to use two 8-bit unsigned integers. All right, so we say first 8-bit integer, and this is going to be, of course, unsigned byte, so we're just going to say byte, and we can just keep this in line with the rest of our variables right here. And we're just going to initialize this byte to 0. Okay, we just can do that. Now the next thing, we're going to define our second 8-bit, which is also a byte integer, and then we'll need to be able to calculate the sum. So the third value that I'm going to add here is going to be the sum, right? So 8-bit sum. So these are possible names for these variables, because these variables we have they have no meaning, just unique identifiers for these variables. Then we need to input two 32-bit signed integers. So here can just duplicate this and say this is first 32-bit and second 32-bit, and here we need to I misspelled this, so I need to fix it, and here this is going to be the difference. Okay, so we're going to say difference 32-bit. Okay, something like this. And of course we have to fix the data types over here, so those will be double word values. Remember that specifically for signed double words, we also have SD word, so we can use these to be specific. SD word, we can use this memory allocation directive. So these things, such as byte and signed double word, simply allocate memory. Byte allocates 1 byte in memory for each of these integers, and double word or signed double word allocates 4-byte size integer in memory. So these are the data, and this is what we need to be able to input and make computations with. Now, I also want to say that we need to interact with the user. So of course we're going to ask the user enter. So let's start with just some of these prompts. I think I'm just going to remove the existing prompts. I'm not going to print semicolon. Instead, I'm just going to print carriage return, line feed, and then 0 for my line ending formatting when I produce my output. Let's change this to bad input format. Right, and we can tell the user that we think that something like this. Right here is a bad input format. Try again. Okay, something like this. We also can report arithmetic overflow, right? Arithmetic overflow. So this is the second error that we may be able to report to the user, and here we can also have them retry. So we'll just say arithmetic overflow. Okay, so this looks okay. So these are some of the user interaction lines that we can produce. Now we also can say input first 8-bit, right? And we can define this byte as enter we can say enter first 8-bit unsigned int. Okay, so that's good enough. Also remember that we need to terminate these string literals with 0 because they're not automatically 0 terminated in assembly. Alright, so then we just copy and paste second 8-bit, so enter second 8-bit unsigned int. We can try to align this a little bit like this, and then we can duplicate these to prompt for 32-bit. Right, so we can use the 32-bit prompts, very similar to this. Enter first 32-bit signed int. This time the 32-bit integer is supposed to be signed numbers. 32-bit signed integer. Okay, so we'll just keep these prompts, and again I'll just try to align all of these at the same justified level right here. On the right hand side there should be all justified, which is easier for the user to work with. So second, I misspelled here and here, so we'll just fix that. Okay, very good. So what else? We also may be able to display that looks like this. So we say sum of two numbers, so we can say sum 8-bit to report to the user. Sum is, and we can display what the sum result is, so we're just also going to terminate it by null, and let's align it like this as well to keep everything justified to the right. And we also need to display the difference for 32-bit. So differences diff is, so we're going to use all of this, and this will be our diff prompt diff like this. So I try to align everything to make things more or less readable. We can also always insert some extra blank lines to see what our user interaction is going to look like. So we can now save this. So we have a little bit of a setup. So we have our constant data segment right here. I brought it to lowercase to make it highlighted in our code. And so these are the strings that we're going to be printing. We have a nice end line output to format the end of line. We also have our two memory buffers that we're going to be using with our input-output macros right there, and also conversions. And we have 8-bit unsigned integers defined as bytes, we give them names, and we have signed 32-bit integers that we also give them these names. So now the next step is to start coding, and of course the first step is going to be to get input from the user. Alright, so we're going to use our sample program to be able to copy and paste. And I don't think I really need this page anymore. I just can maximize this view and continue my work, knowing that we already have all the all the configuration of our variables ready to be used in our coding solution.